Are you interested in some ideas for building your own dipole antenna? Well, that's what I'm going to be doing today, so stick around and see if you can pick up a few ideas. Hi, Steve here, Kilo 4 Sierra Romeo Foxtrot. Today I'll be building a 3-element dipole. It's going to be consisting of 40 meters, 20 meters, and 10 meters. I'm going to take you through the complete process of designing it up to the construction of the element. So let's get to it. Okay, after determining that I want the 40 meter, the 20 meter, and the 10 meter on my fan dipole, I've plugged some numbers into an Excel spreadsheet that I've created. The simple formula to find out how long you need in feet for each element. To find that answer, the feet length, you just take 468 and divide it by the frequency in megahertz, and that'll give you actually, that's what I've done here, and it gives you the element length for each one. Now, 40 meters, I'm going to need just over 32 feet in length. That's for each element. The 20 meter, I'm going to need just over 16 feet. And for the 10 meter, I am going to need just over 8 feet. Now that I've determined how many elements I need 3 elements, one for 40, one for 20, one for 10, and the length I need. Let me go ahead and see if I can get a visual of what this the fan dipole wing is going to look like. Okay, first off, don't criticize my drawing too bad here, but I'm going to draw this out in paint, and this is definitely not to scale, so it's not meant to be to scale. So I'm just giving myself a visual what it's going to look like, basically, as far as the design itself. And what I've got here is I'm going to have my, get in here. Here we go. I'm going to have my 40 meter here. I'm going to have my 20 meter here. And I'm going to have my 10 meter here. And just to kind of make it a little neater, I'm going to put one of the eyelets right here, one of the eyelets right here, and one of the eyelets right here. Just gives me an indication of where it's going to be. Now, I'm going to have to figure out how many spacers I need here, and I'm thinking about having three 3-wire spacers and 1 2-wire spacer. Now, these right here I'm going to bring together somewhat. I couldn't do it here in paint, but so I'm going to put 1 3-wire space. Well, let's just get back to the right line here. I'm going to put a 3-wire spacer right here, close to the eyelets. I'm going to bring them closer together, and then the second 3-wire spacer. This one's going to be. I'll figure that in a second. This second one's going to be right about here. They're going to be these are going to be 6 inches apart between the elements itself. To be determined as how far these are going to be apart here, I'm going to need to play with that a little bit. And the third one is going to be right about here. And that's basically, of course, like I said, this is just a rough view. This is going to be where the 10 element ends. Now we'll have a 2-wire spacer right here. And this will be where the 20 meter terminates. This right here will go on to, I'll make this like that. This is going to be an insulator. And then from there, I will have basically a wire or a rope or something tying it off somewhere. This will be the tie down right here. We'll make that as a tie down. Okay. Now, like I said, these elements, I'm going to have this one close to the eyelets so I can keep them together. This will be the third one. This is going to be 14 inches. This will be 14 inches, figuring out the math, and the 14 inches. So what I'm going to do, and this will be 8 inches. So let me show you how I came up with these lengths here. All right, we'll start with the 14-inch spacer here. Now, the way I figured this is I want to have 1 inch from each end open, And that is where one wire will go and one wire will go. So if this is 14 inches, what I'm going to have to do is do the math and add 6 to this. That's 1 inch. 6 inches from there is going to be 7 inches, dead center in the pole, and the third element right here. So what we're having here is the first wire will be at 1 inch. The second wire will be at 7 inches. And the third wire will be at 13 inches, since this is a 14-inch spacer here. Now, that's going to keep 6 inches in between wire 1, 2, and 3. Now, on the 8-inch spacer, this is 8 inches here, and it's only going to have 2 wires, so I'm going to have 1 inch in, and from the end, 1 inch in, and that will give me, this is 1 inch, and this will be 7 inches. And in, oops, well, let's try this again, 7, there we go. All right, 7 inches. Now, in between 1 and 7, that's going to be 6 inches. So that'll give me a 6-inch space in between these elements here. That's how the spacers are going to work out. Okay, after we've determined what our element lengths should be, we go ahead and measure them out and cut them. And I'm just using this yardstick here to measure my elements out to the desired length. I'm going to give it a few inches over so I can trim it back if I need to. It's easier to trim back than it is to add to the wire itself. So let's go ahead and measure this out and then we'll cut it. Okay, now that we have got our wire cut, I'm going to have to go ahead and install the eyelets here to be connected to the insulator. Now, for the sake of simplicity, I'm just using a spare piece of wire, and I'm going to sacrifice a piece of wire and an eyelet to demonstrate this. I've already installed the eyelets on the other wires, and I did that and forgot to record it, so I'm going to go ahead and just sacrifice a wire. So to install the eyelet, first off, you want to see how much wire you need to have through here. And I'm using, by the way, 14 gauge stranded copper wire for my antenna elements. Again, 14 gauge. I just found this to be a more suitable gauge for me to use. You can use different gauges, but in my case it's 14. So I figured out I need about how much wire I need to strip off of here. So I just measure that with the end of the eyelet in the opening of the eyelet. Stick it into my wire strippers here. Give it a tug. There you go. Most of the time you get enough. Sometimes you got to trim a little more, but most of the time you can get it right in the first one. Okay, yeah, that's more than I need. That's just perfect. So, as you can see, the copper wire is sticking out just a tad here. So I've got enough room to play with. Next, I need my crimpers. Now the crimpers, some crimpers are different. Some, they're different, but they basically have the same idea. This is a blue coupler there. I just put it into the hole here. It's got a blue dot on it. I don't know if you can see that too well, but it goes in there. What I do, be honest with you, my idea is to stick it into the corresponding hole and I'll clamp it down just enough to hold it. Then I'll take the wire after clamping it down, inserting it into the hole just so the copper wire is showing. Then I go ahead and press it downward and clamp it down. That's on there pretty secure. That right there, that is pretty secure. But I want to go ahead and give it a little extra connection, or a little extra connection here, possibly, or if you want to call it that. So what I'm going to do is I'm going to attempt to brace this thing up. You can use helping hands too. I just don't have them ready available right now. There we go. I got it up here. And I want you to know in advance that my welding skills are not the best. So with that being said, get it back into camera view. I am not a welding expert by any chance, so if you're gonna say something mean about it, do it now. Once I can get this wire to cooperate and stand up. In the meantime, while I've been doing this, I'm getting my iron hot here. Here we go, and now I'm gonna go ahead and just test it. Yeah, okay. Go down here. And what this is doing, this just provides a little bit more connectivity between the wire and the eyelet itself. Well, if at first you don't succeed, try again. You just want to make sure you got enough solder in there that makes a good connection between the eyelet and the copper wire itself, which in this case it did. Looks pretty good. We'll let that cool off. Then we're ready for our next step. Okay, in this step we're going to go ahead and measure our pipe. We've already determined we want to have, for the 3 wire sections, 14 inches. So I'm just finding 14 inches on my yardstick here and mark the pipe accordingly. 14 inches right there. Now, I'm not going to repeat this step for the 2 wire spacers. I'm just going to do this for the 3 wire spacers. For the 2 wire spacers, measuring and cutting is identical. It's just a different size pipe. So I'm just going to do this for the 3 wire spacers here. Now we've marked our pipe at 14 inches from end to end. And at this point now we need to go ahead and cut our pipe. Okay, now that I've got my pipe marked, I've got the mark right here. I'm going to line it in with a center hole. You can use a saber saw, a jigsaw, hacksaw, whatever you want to use. I have decided to go ahead and use a miter saw with a miter block here. I'm doing this indoors so I can clean this up anyway. And this is not going to hit the floor at all. So once you've got your mark lined up with your saw, make sure the saw is dead center of your mark here. Just go ahead and start to saw it until you get the pipe completely sawed in half. All right, now I have my 2 14-inch spacers here, ready for the next step. Okay, now I'm ready to mark the location for the drill holes for the 3 wires. Now I have 3 wires in this 14-inch here, and I want to space them out 6 inches apart. So what I'm going to do is mark the first end at 1 inch, which is right here. And remember, these don't have to be exactly right on the money. And the second one at 1 inch in, which is right here. You just want to get just as close to it as possible. Now, you're going to go ahead, this is going to be the location of 1 wire right here. And 1 wire right here. I'll show you what else I'm going to do here. Now, I want to go ahead and put this 2 wires. I want to put the 3rd one in it. So it's going to be in the center between here, which is going to be the 7-inch mark. That's 1, 2, 3. I'm sorry. 1, 2, 3, 4, 5, and 6. Since they're 6 inches apart, here is the 7th. So that's all 3 holes. Now that's where they're going to be here, but I want to make sure that I can go ahead and get these holes lined up as evenly as possible. So what I do here, and I'm going to try to do this upside down, is I'll stick the pipe in between the 1 inch mark. This is a 3/4 inch pipe, I believe. And I'll try to center the pipe just visually as best I can. And I'll mark on like a cross line here. And then I'll reverse the process and do the same on this side. As close as possible. It doesn't have to be exact. this is not a precision machine tool item. Then what I will do, as you can see here, I've put a mark here and a mark here. Like I said, this is not a precision instrument here. We're not building a spaceship here. So what we're going to do also, and then take a ruler, and to the best of my ability, line up these two end lines right here. And the best of my ability here. And I am going to mark a center line. And so therefore I've got 3 lines here. And they may not be exact, but they're going to be close enough for government work. They're going to be up in the air. Nobody's going to notice if they're slightly off or not. So, time for our next step. We're going to go ahead and drill the holes. Okay, moving my operation outdoors for obvious reasons. I don't want to drill a hole in my floor by accident. I locate the cross hairs on the pipe, line up my drill bit, and what I did was I just drill holes in a pipe. If you've ever done that before, unless you do it precisely, you can have the holes will be uneven. Even if you really try, they can really be uneven. So, I've got myself a little tiny, I guess you want to call it a pipe brace to put the pipe in, and this is on obviously a press, small drill press is what it is for pipes, and you can drill a hole straight through and evenly. So go ahead and line up your crosshairs and just drill. Alright, that one is completely through. Now, this other ends, on the ends here, since you can't actually place this across here, you can't brace it, I just hold it as firmly as I can. I wouldn't suggest doing this with metal pipe, obviously, but PVC, you can pretty much do it if you got a steady hand, and just drill until you feel it coming through the other end. And it came through, and looking at it, I can't show you on camera, I don't think it will show, but you can tell it went all the way through pretty square, pretty straight hole there. And again, repeat the process on the other end at the crosshairs. And I want to emphasize again, this is not a precision machine part that you're making here. Okay, now all 3 holes are drilled, and we're on to our next step. Okay, our next step is to go ahead and clean and sand the little pieces off the pipe here, basically on both ends. Just sand it down some, and then clean it. I just go over it slightly with the sandpaper here, like I'm doing here. Checking again to make sure there's nothing really sharp. It's not going to hurt anything. It's going to be up in the air anyway, but I just want to sand it down some, rough it up a little bit, and next we'll just run it under some water. And what I do is on this point I just take it into the kitchen or wherever you want it, or on the hose, whatever you want to do, and just wipe it down with some fresh water, just water, rinse water, and take a paper towel and dry it out. And then bring it outside because we're ready to paint these things. Okay, now it's time to paint this guy, the spacer here. You don't have to paint it. I just decided to paint it. And you can paint it any color you want. I've chosen to paint mine white. Now, the reason I'm painting mine is to cover these markings up here, like the barcode here and any other markings. Some of them have markings on them, like you can see here, some writing. I just want to paint those over. I just want to paint these over. And I've chosen white, and I've also chosen a non-metallic paint. You know you're not supposed to paint antennas with metallic base paint or metallic flake paint or anything like that. I've just chose an inexpensive brand from Home Depot, paint it white. Like I said, you don't have to paint it, or you can paint it any color you want. And I just shake up the can like you, well, probably know how to paint stuff, but also make sure the wind's at your back. I'm doing it especially with the wind in my back because I've got the camera here. What I'll do is I'll just paint over the white, and yeah, I I got wind blowing back on me. It doesn't have to be a perfect paint job either. And I usually just paint one, I give it a couple coats, but I paint it once on one side, then I'll let it dry out. And what I'll do is I'll show you the one I've already got painted here. I just let that I'll let that one side dry, and then I'll go back, give it a second coat, and then paint it again. Now here's one I've already gotten done. It looks pretty good. It's not a perfect paint job. You can still see some bleed through here. I'll just go ahead and give that another coat just to cover it up. And basically, that's all I want to do is just give it a coat. It's going to be outside and everything, so it's not really imperative. It's not anything to do with the spacer itself other than just to give it a clean look. And again, you don't have to paint yours if you don't want to. I just chose to paint mine. Hey, I have a quick tip for you here. If you decide to paint your PVC spacers, you'll find that most of your pipe commercially will have these markings on it. They'll have the like the barcode marking here. Plus I'll have a description of the pipe itself, and usually printed in red right about here, or maybe another color, I'm not sure. But anywho, if you decide to go ahead and paint these, you'll find that the thinner in the spray can itself, the paint itself, will actually cause this ink to bleed and to run. And this is going to cause you to have to give your spacers multiple coats of paint in order to cover up all that bleed and running of the ink itself. Now, my suggestion is, for one, do the following outside: no fire, no flame, away from all the fire and flame, since it is flammable. But I recommend using acetone as opposed to paint thinner. Paint thinner will probably start to melt the PVC pipe itself. But use acetone and paper towel outside and wipe down this pipe maybe 3 times, or until you're satisfied where the all the ink and the runoff is pretty much gone. This will assure that you don't need to multiply paint or multiply coat your PVC pipe. You don't have to give it several recoats. I recommend probably 2 coats of paint, and I have done this in the past and not taken this off, and it's caused me to actually give it about 5 coats of paint in order to fully cover it. So you're saving paint, you're saving time, and you're saving a headache. Now, to show you what it's like, I've got a pipe here that I did previously, and as you can see, all the markings are completely gone. I do have a little bit of faint magenta in here from the print, but that would be easily covered in 2 coats of paint. So taking that print and the markings off the pipe to begin with will save you a lot of time, a lot of headache, and get your antenna up in the air that much quicker. Well, this is the first wing of my fan dipole, and the elements are completed here. I've got it tied down on a cat post and stretched across my living room floor for demonstration purposes. The first spacer you'll see is a gray one, small gray one. That's where the 3 elements are running through. That's just to line them up to give them a straight shot to the insulator that I'll be mounting this to. Not using a balun on this particular fan dipole, I'll be using an insulator. The first spacer here, the 14-incher, see the wires going through. Once all of these are in place and pretty much online, I will glue the individual elements in place after I've got everything tuned. This is the second spacer. On the top is the 10 meter band there. That will be terminating at that particular spacer there. Once tuned, I will secure that into place. And again, there's 6 inches in between each element. The top element here, wire you see, is a 20 meter, which terminates at the third spacer, which is the 8-inch spacer. As you can see, it's terminated there. As soon as that gets tuned, that'll be glued into place. The 40 meter continues on its way and will be terminated after tuning onto an insulator and then tied down. Now, mind you, I'm showing you this antenna upside down. Once installed, the 10 meter will go on the bottom, 40 meter will go on top. Okay, now once I get the fan dipole up outside onto the insulator, I'm going to make sure that the spacers are in the right spot. And then in the past, I've had spacers actually shift in the wind some. They'll get this way, get that way. Anyway, I want to keep and keep them as permanent as possible. So I'm going to do that by using a glue gun. I'm not going to do it right here, but I'll give you an idea. When I get it in place, I will use a glue gun, and then I will apply glue. And I got 3 holes right here, with 1 on each side. I'm going to apply a drop of glue on each of the holes here, and on both sides, and that should keep the spacers in place on the wires. It keep them from shifting and moving, sliding up and down. It'll keep them pretty permanent. But again, I'm not going to be doing that until I get this elements installed onto the insulator. But I am still waiting on a couple of things to be delivered before I get to that step. So I will not be actually covering the erection of the fan antenna in this particular video. That'll be covered in another video. I'll be showing the what it's like after it's been installed. So that's my part about gluing these things. I think it's a good idea to go ahead and glue these. It will, like I said, keep the spacers from freely sliding back and forth. As you can see, they can do here. A drop of glue on each hole will keep them pretty secure. Well, I hope my video has been some help to you if you've been planning to build your own dipole. Maybe it'll give me some ideas. Each design can be a little bit different. Each design can have their own challenges. So till next time, this is Steve, Kilo 4 Sierra Romeo Foxtrot 73.